we will now discuss about midpoint theorem. So this will be midpoint theorem. So what it says basically, so this midpoint theorem will be used in solving many problems, and this is a very interesting theorem. It says the line segment joining the midpoints. Remember, the midpoints of two sides of a triangle. Remember, we are now talking about a triangle. So the midpoint theorem relates to of a triangle is parallel to the third side. Is parallel to the third side. So why we are discussing this after discussing the parallelogram? Because this is the combination of a triangle that we have studied and also parallelogram that we have been studying. So let us see what it says. Basically it says that you take a triangle. So I have drawn a triangle after a long period of time. Okay, so let this be a triangle and let us call it A, B and C, and let us find out the midpoints. Midpoint of AB, let us say this, and midpoint of AC, let us say this. So let us call, first we picked up B, so I will call this one ABC, and I will call this one D. This would be E. Okay. If I join D and E, this should become this should DE should be parallel to prove DE is parallel to BC. So what we will do? First of all, I will extend DE to, let us say, extend DE to F. Okay. And let us draw these two parallel. So let us draw CF parallel to. So construction. What is given? Given ABC, a triangle, okay, D is midpoint, therefore BD is equal to AD, and also E is midpoint of AC, D is midpoint of AB, okay, therefore BD is equal to AD, AC, therefore AE is equal to CE. Okay, these are given. So what I have done by construction? So construction, I have extended DE to F and drawn CF parallel to BD. Okay. Now, if I have drawn that parallel to this one, then let me take these two triangles. Then let me take this triangle and this triangle. Okay, what I want to do? I want to prove that they are congruent. First thing that I have, so the triangles, let us take triangles ADE, which is parallel and triangle CEF. So this is a triangle and this is also a triangle. Okay, AE, AE is equal to CE. So this is known, this is given, this is given. Have I written somewhere? AC, AE is equal to CE is given, and let us say angle 2, let me nomenclature it, angle 1 is equal to angle 2, angle 1 is equal to angle 2, vertically opposite angles. Angle 1 is equal to angle 2. We have one 3 and this one 4. So I have angle 3. Angle 3 is equal to angle 4. That is alternate opposite angles. ठीक है? Okay. So therefore triangle ADE is congruent to triangle CEF by what will be? Angle, side angle. Angle, side angle axiom. Okay? So what do I get out of this? So from here, I will come here because there is some space available here. And there I will prove that this is then that AD is equal to CF by CPCT. Okay, so this is this. BD, which is half of, BD is equal to half of AB, half of AB, therefore is also parallel to, it is also equal to CF. BD is also, I think this D is going away a little bit, let me put it so that there is no confusion. So BD is parallel to CD. Therefore BCFD is a parallelogram. If BCFD is a parallelogram, then we can easily say, therefore you can say DE is parallel to BC. DE would be parallel to BC because this is a parallelogram. Okay. Also, you can easily see DE also is equal to EF by CP. Okay, So DF is also equal to CPCT. So this is parallel to this one. You have got, there is, let me explain to you the whole thing. We first had this triangle. These D and E are the midpoint. They are joined together and we have to prove DE is parallel to BC. What we went through a construction, it is DE is extended, and and you draw from C, CF, which is, you can again extend this also. CF is extended and this is intersects at F, and you have taken CF is parallel to ABA. Okay, then what we picked up these two triangles and we proved them congruent. How we proved them congruent? AE is equal to CE, which is given. Angle 1 and angle 2 is vertically opposite angles, and because I have drawn CF is parallel to BA, then I can say angle 3 is equal to angle 4. So these two triangles are congruent by angle side angle axiom. That is done. From there, what did I do? That I said AE is equal to CE. What is AE? AE is equal to CE. That is given. AE is equal to CE. I have taken AD is equal to CF, that is CPCT. I should have written this one here, and I have taken DE is equal to EF, that I have taken. That is, this is equal to this. Okay, so then I have taken BD. BD is equal to half of AB. So BD is also, since AD is parallel to CF, so I have taken BD is equal to CF, and proven BCFD is a parallelogram. Therefore, DE is parallel to BC. Okay, this is proven. We are again going to do another theorem on midpoint theorems, and here I am just the reverse of what we have discussed before, and so I will show the difference. Here what we are going to do, the line segments will remain shared, so instead of doing this joining, it should be passing, okay, passing through. So you need a through. I don't think this is a very good chalk. Anyway, we will try with this one and let us see where we go. So it should be passing through the midpoints. It will now go away. It will be a midpoint. So passing through the midpoint of 1 instead of 2, it should be 1. So it should be 1, O-N-E. So it should be one side of a triangle, and instead of is, it should be another of a triangle, and so I have replaced it with and parallel to another, instead of third to another side, bisects instead of bisects the third side. To bisects the third side. So now the difference, you see, it is this thing, okay, the side was there, okay, we should cut it. So it says the line segment, passing through the midpoint of one side of a triangle and parallel to another this side I should not have cut, another sides bisects the third side. So this I have, you see the change. So the midpoint remains the same of one instead of one side, and this is our theorem. And this we have to prove. Now we have proven, this was proven like this. Now instead of that, what do I have to prove? I have to prove that AE is equal to CE. AE equal to CE. So this is I have to prove. I should have used the other chalk. So I will now say and tell you that AE is equal to CE. So this is what I have to prove. Construction remains the same. Okay, so I have extended D to this thing. It is also so D is the midpoint of given. So D is the midpoint of D is the midpoint of AB. Okay. Okay, DE is the midpoint of this given. Okay. Now what is given? What is given? And okay, here it is all written here. Now also E is the midpoint. It is not. This will not be there. E is no longer. This is what we have to prove. This is not given. Okay, so all it is said that here, and therefore this is also not there, so you cannot use it. All you have now here, DE is parallel. This is given. This is given. This is now given. This is now given. So DE is parallel to BC. This is given. Okay. What is given are these things. Okay, I am using the same thing. This is not, this is, we will go beyond. So this you should understand. And this is okay. I will now prove that if this is then we will say, what we can say here, here can say BD, oh no, why did I go to D? BC, FD. BC, FD is a parallelogram. Okay, so we will get that. Okay, if BC and FD is a parallelogram, then we can do one thing, that we can say BD is equal to CF. BD is equal to CF. Therefore, BD is equal to CF. Okay, so BD equal to CF. And then I can say BD is also equal to AD given. This is given. Okay. Okay, in that case, BD is equal to CF from this here. Therefore, I can say BD is equal to CF. Now again consider these two triangles. So this will continue. There is no change. This is not given. Angle 1 is equal to angle 2. This is okay. So this will change. This is not given. So instead of that, what you have now, BD equal to AD equal to here, okay, instead of BD equal to CF, it's already given here, so there is no use of writing it again. Therefore here it will be AD equal to CF. Okay, so this was not necessary, it's a repetition of the same thing. It should be AD equal to CF. So here I'll write AD equal to CF. Okay, so this is a congruency is there. And in this case, what would be the congruency? It will be the congruency of AAS axiom. Why I am rubbing it again? It will be now AAS axiom. Okay, it will be now AAS axiom. So this is all right now with you. So these two triangles are congruent. So what do we get? Now if these two triangles are congruent, and then I can write AE from here. From these two triangles are congruent, so from here you go through and come here. Come here, so these will be not necessary because we don't have to prove it is a parallelogram. This is not necessary, this is not necessary, this is not necessary. So these will all go away. All you have to now say that AE, okay, I'll use the other chalk because this is different. AE is equal to CE. AE equal to C. So that is what we have to do. And it is bisects the third side. That is, so to prove, as I have said, AE is equal to CE. So this is AE is equal to CE. This is, I should write CP CT, which I frequently forget. AP equal to CPCT. So now you understand, I superimposed on what I have done before and showed you what are the changes are required. So this is a line segment passing through the midpoint of one side of a triangle and parallel to another side bisects the third side. Okay, so what you have to prove, that previously we have proved this is parallel, we have to prove AE is equal to CE. Constructions remain the same. So to prove, that means we are going to prove that D is the midpoint of this thing. So this is now what is given. Given DP is the midpoint of D is the midpoint of AB. So therefore BD is equal to AD, and it is also given BC FD is a parallelogram. Why? Again let us repeat this. Why? Because it is said, it is given DE is parallel to BC. So that means DF is parallel to BC. DF is parallel to BC. Okay, from here, because DF is an extension of what you can say DE. Okay, there is an extension of DE. Okay, in that case, and I have already drawn BD. BD is parallel to CF by construction. Therefore, BCFD is a parallelogram. Okay? So BCFD is a parallelogram. And since therefore it is BCFD is a parallelogram, we have shown you that here I have written BD is a parallelogram. Okay, so this is already shown here. BC is already shown here is a parallelogram. I have given an extensive proof that since this is a parallelogram, I can say BD is equal to CF. Then I have said BD is equal to AD. This is given, and this is again therefore AD is equal to CF. That is obtained. I cannot say this is part of the proof. Okay, this is from properties, PROP, properties of a parallelogram. Okay, from properties of a parallelogram. Now once I have done this, I have gone here to show between the difference between, I have proven same congruency I have proven, but I have taken different ones, and that is I have shown you these two triangles are congruent. Previous also the one we have shown is the congruence. What is the difference here? Here I cannot use this as given, but these two things are alternate opposite angles. Those are there. Alternate opposite angles, those are there, and AD equal to CF, that we have proven, and then therefore these two triangles are congruent. As these two triangles become congruent, then what do we get? We can say from CPCT, have I written it here? Yes, here I have written AE is equal to CE. So this is done. So you saw one and the other is the converse of the other, and this is over. This would be example 7, page 149, NCERT book. Okay, what it says, in a triangle ABCD, so this is telling you what is the ABC, not D, because it's a triangle, it comes out of your this thing. D, E and F are respectively midpoints of AB, BC, AC, right? BC and AC. Okay, so there is nothing, so comma will not there, and AC. Okay, so that that triangle ABC is divided into four congruent triangles by joining D, E and F. Before I start the solution of this, and just to explain, the solution is given in the book. So why I am doing it? Why? I am explaining it to you. Now, what is the meaning of this respectively? People get confused. Respectively means you start as it comes. That means D is of AB, E is of BC, and F is of AC. Because this comes in this order, and so you have to take them in this order. That is the meaning of respectively. Don't get confused. Now ABC is divided into 4, so this is giving you number, and this has to be congruent. You see, understanding the question is very important before you attempt the solution, because you can attempt to give a solution which will be completely wrong, and you will get a 0 mark. So this you understand what it means. Okay, so what I do, I first draw a triangle. I'll draw this triangle bigger a little bit. Okay. Then I will mark it, and so it is already given how I have to mark A, B and C. So I have done at least one job. Then I have to find out the midpoints. So AB's midpoint is D. So this I will mark it as D. BC's midpoint is E. So this I will do it. And F is the midpoint of AC. So I have done up to this. Okay. Now it is saying that you join DE, you join DE, you join, and you join DF, and you also join AF. So what do you see? You see 4 triangles, right? That I have to show it to you? Yeah, I will show it to you. This is 1 triangle, this is 2, this is 3 and 4. So all I have to do that prove them that they are congruent. So division into 4 is a 4 is already accomplished by joining. So I have shown 4. So what I have to show them? Congruent. Okay, what do we do? We start with AB first. If you see AB and this is EF is parallel to AB, EF is parallel to AB. Okay, DF is parallel to BC, and EF I have already taken AC, so I have to take AC. So DE is parallel to AC. Why I am able to do that? Because it is said join midpoint of ABC. And so joining, I have joined. As soon as you join, so this you can indirectly say this is given. Because as soon as I join these midpoints, this will be parallel. That is, we have done both the theorems in the earlier, before this problem, we have done it. So this is a very good application of that point. So this is given. As you have given these two, then you can find out AD. So ADEF, ADEF is a parallelogram. So which one I am talking about here? I am talking about this parallelogram, this one. Okay, now, and again you can see that because DF is parallel to this, then what you can say, DB. So DB, I'll start from here, DBEF. Is a parallelogram. Next, what is this? DE is parallel to this. Then what would be the other one? Other one would be, I have to see ADEF, and the other parallelogram will be DECF. So DECF is a parallelogram. Now the trick is why I am choosing only these parallelograms. So I have chosen, what are the parallelograms I have chosen? I have chosen ADEF, DBEF, DB. So this parallelogram I have chosen, and DECF. This is the other parallelogram that I have chosen. This is the other parallelogram that I have chosen. Okay, the colors are same. So what difference it is make if I use the same one? Okay, this is the other. Why I am choosing only these parallelograms? There are other forms, so that I can get a diagonal across it. So if you see 1, so let me put down it as 1, this is 2, and this is 3. So if I take ADEF as a parallelogram, let me come to this side here, because there is a lot of space here, otherwise I have to go down. So ADEF, then DF is the in parallelogram ADEF. ADEF, you have DF as a diagonal. So then triangle ADE, ADF would be congruent to triangle DEF. So this triangle and this triangle, they are now becomes congruent. Okay. Now again, it's confusing. Okay. I have taken this triangle. Then let us come to this triangle. See, you again have a diagonal. You choose those triangles which parallelograms which have a diagonal. So in parallelogram DBEF, you have DE as a diagonal. Therefore, if you have DE as a diagonal, therefore triangle DBE is congruent to triangle DEF. DEF. So this triangle, I will put now this kind of thing so that you can understand. So these two triangles are congruent. Okay, now you say parallelogram. In parallelogram, DECF, so DECF, EF is a diagonal. EF is a diagonal. So here, therefore, DF is a diagonal, EF is a diagonal. Then again, it is a central point, and these two triangles. So I will put again here a star, and here a star. Okay, I will call then DEF, again DEF. DEF is congruent to D, I have said, so I will start with D corresponding is F. F EC. So what we have got? We have got ADE, ADF. What do I write? Okay, I have no other choice but to use this because it will go a long way. So I have got triangle ADF congruent to triangle DEF. Again I have, so this is congruent. So since this is also congruent, so I can say triangle ABD, triangle DBE, yes, DBE, again that is congruent to triangle DEF. This is given, again DEF. Okay, that is again congruent to triangle F. From here, FEC. So this point is from, let us call it A. This is from A. This two is from, again from, let us call this B. Let us call this B. So this is from B. And from here to here, this is C. Okay, you see that this middle triangle is the bridge between this and this, this and this, this and this. Okay, so DF is always coming here. So these are the four triangles. So 4, why don't I use 4 as such, 4